Hello there, welcome to this video, and for this video I will explain to you about the separable variables. Separable variables is just one of the many ways in finding general solution for an ordinary differential equation. So technically, separable variables is more likely algebraic manipulation. If you know how to manipulate variables, if your foundation in algebra is, you have a strong foundation in algebra, then this method would be easy for you. It would not be hard for you. So what we'll do is we'll find the solution of the given. We have the two givens. We have the number 1 and the number 2. So this is the easiest way in finding a general solution, and after this one a particular solution. So we'll answer number 1. For the number 1 example, we have the quantity of 1 plus x squared dy over dx plus xy is equal to 0. So find the general solution of this one. Okay, so if we observe, it is written in dy over dx, so we prefer to write dy over dx than writing it in y prime or f prime of x, because we will separate the dy and the dx, the y families for the dy and the x families for the dx. So that is this is the concept of separable variables. It's just like manipulating algebra. I mean, the way of separating the variables is just like you're doing algebraic manipulation. So we'll start this one. For the number 1 example, since we have dy over dx, what we'll do is we will multiply both sides. We will multiply both sides by dy over dx, I mean dx. So what will happen is 1 plus x squared dy, so dx will no longer be in the denominator, so plus xy dx is equal to 0. So that's the purpose of multiplying dx. We want to dissolve the fraction. Okay, so after doing so, the next step is we will segregate the y and the x. So for the dy, we will put the y, we will put y for the dy, and for the dx, we will put all x here, all x variables. So how to do that one? So simply, we wish to put this 1 over x squared in dx. So what we'll do is we just multiply this one by 1 over 1 plus x squared, so that this 1 plus x squared will be cancelled out after we multiply. Then next is we want also to cancel out y in the x families and dx and put it here in dy. So of course we'll multiply also by y, so that if I will multiply this one, the y will be cancelled also. So look what will happen. I multiply this one to the first term, so 1 plus x squared will be cancelled. So what will be left is dy over y, because we have the y. And for the second term, dx will write x, and dx, y will be cancelled, so we have the remaining, which is y plus x squared is equal to 0. If we multiply this one to 0, it's still 0. Okay, so after we segregate this one, after we separate the variables here, it's time for us to integrate term by term. Okay, separate then integrate. That's how to find the solution to differential equations. So we'll integrate this one. We will not forget to integrate also the 0. So the integral of dy over y is simply ln y. Then we have this one, the next one. So for this one, we will let you this one, we will let you our 1 plus x squared let u would be 1 plus x squared. So du would be 2x dx. Then divide both sides by 2. So what we left is x dx equal to du over 2. So from the original expression, what will happen is ln y plus the integral of 1/2 du over u. Okay, this is our u, and the du is equivalent to x dx, or du over 2. Then of course the integral of 0 is constant. Okay, so the integral of du is just like we did before. The integral of dy over y is ln y. So 1/2 the integral of du over u is ln u. Our u is 1 plus x squared is equal to c. Okay, so after this one, after solving this one, by property of logarithm, when you see the plus sign, meaning you have to multiply this one, and if there's number here beside the natural log, we can put this one in our exponent. So what will happen is ln y plus ln square root, or 1/2 or square root, is 1 plus x squared is equal to c. Then we can multiply this one. So ln y square root 1 plus x squared is equal to c. So we are not yet done, because we want to solve this one in terms of c. Okay, I mean in terms of y. So we will dissolve the ln, the natural log. So we will raise this one both sides by e, the constant e, both sides here. So what will happen is this will dissolve, cancel out. So y is equal to y times 1 plus x squared. Square root of 1 plus x squared is equal to c, where c is c sub 1, where c sub 1 is equal to e to the power of c. So our final answer would be this one. Okay, now back to our example number 2. For example number 2, we have the example number 2. Just like we did before, we will segregate the x variables and the y variables in dx and dy. So by just multiplying. So we'll put second x here, because second x is located in the y families. So we will put this one in the x families. So we'll multiply both sides by 1 over second x. Okay, so if we multiply this one to the first term, it would be x dx second x. Okay, so this one, so this one. Then next is for the second term, second x would be cancelled out, so sine y dy is equal to 0. Okay, so after separating all the variables within the respective families, we can integrate each term. So the integral, okay. So I will write this one, the second x, in terms of cosine. I can transform this one, because 1 over second x is equal to cosine x. So what will happen is x cos x dx plus sine y, the integral of sine y dy is equal to the integral of 0. Okay, so if you look at the first term, it is written, it is two functions. Okay, it's composed of two functions. So it's composed of two functions. We will use the concept or the method of the integration by parts, or simply known as the DI method. So we'll start solving this one. In IBP method, or integration by parts, you need your u, we need our u, and we need our dv. Okay, we need our u and our dv. So the integral of u dv is equal to uv minus the integral of v du. Okay, that is the integration by parts. So this time we will let u be our x and dv our cosine x dx. Okay, we'll not put c here. So we'll simply substitute. Our u is x, our v is sine x, minus our v is sine x, then our du, in our du is dx. So we'll put dx here. So we can now integrate sine x because it is easier to integrate sine x alone. So x sine x minus the integral of sine x, that is equal to, what's the integral of sine x? So this is cosine x. Okay, plus c. Here we go. So the integral of x cos dx is equal to x sine x minus cos x plus c. So we can write the first term here, x sine x minus cos x. We'll not put c, minus cos x. Then sine y. So the integral of sine y is also positive cos x, positive cos y. The integral of 0 is c. So it will be negative. This is negative. So this one is positive. This one is positive and this is negative. So we'll write this one again, x sine x plus cos x minus cosine y is equal to c. Okay, so we can arrange this one. Cosine y is equal to x sine x plus cos x plus c. So this will be our final answer.